What if tonight you could step beyond the familiar glitter of our own Milky Way and set your eyes on a galaxy so vast, so luminous, that it has haunted human imagination for centuries? Look up on a crisp, dark night and you may already have seen it, a faint smudge of light, barely brighter than a ghostly cloud. That blur is no star, no cluster, but the closest spiral giant to our home, the Andromeda Galaxy. Andromeda is not just another point of light, it is a staggering colossus of more than 1 trillion stars, spread across 200,000 light-years. It is a galaxy older than our world, larger than our own, and bound to us by invisible threads of gravity. One day, 4 billion years from now, it will collide with the Milky Way in a cosmic embrace, reshaping the skies forever. But tonight we do not wait for that collision. Tonight we begin a journey inward across 2.5 million light-years to the beating heart of our cosmic neighbor. This is no ordinary voyage. At every stage, mysteries await, vast halos of dark matter we cannot see, rivers of newborn stars swirling in luminous arms, ancient stellar cities in the bulge, and at the very core, a darkness so powerful that it bends space and time itself. A supermassive black hole, silent yet unyielding, rules the center of Andromeda with a grip beyond imagination. But this journey is not only about astronomy, it is about perspective. To travel to the center of Andromeda is to confront the vastness of existence, to glimpse both our fragility and our significance. Every step closer reminds us of the paradox of the universe. We are impossibly small, and yet we can understand it. So let us go. Let us leave behind the boundaries of Earth, slip past the edge of the Milky Way and sail across the intergalactic sea. Ahead lies not just another galaxy, but a mirror, one that may reveal the fate of our own. Our journey begins at the edge, where ancient eyes first mistook Andromeda for a star. For millennia, humans looked up at the night sky and saw what they believed were points of light scattered randomly across a dome. To them, the Andromeda Galaxy was no galaxy at all. It was a single flicker, faint and unremarkable, tucked among countless other specks. And yet that faint blur carried a secret, one that would one day shatter our understanding of the universe. The first records of Andromeda reach back nearly 1,000 years. In the year 964, the Persian astronomer Abd al-Rahman al-Sufi wrote about a little cloud in his Book of Fixed Stars. To the naked eye, it appeared as nothing more than a misty patch. He could not have known that he was describing an empire of stars, each brighter than our sun, each with worlds of its own. In Europe, centuries later, medieval stargazers recorded the same blur. They gave it names like nebulous star or great nebula, thinking it was a cluster of unresolved points. To them, it was local, something that existed within the Milky Way's boundaries. But the truth was far more astonishing. That tiny patch of light wasn't nearby. It wasn't within our galaxy at all. It was an entire universe in its own right, a colossal island of stars floating millions of light years away. The breakthrough didn't come easily. Even as telescopes sharpened, Andromeda remained mysterious. Astronomers could see it more clearly, and a spiral haze, a whirlpool of glowing arms, but its true scale remained hidden. Was it part of the Milky Way, or was it something beyond? By the early 20th century, the question reached a boiling point in what became known as the Great Debate. On one side, Harlow Shapley argued that the Milky Way was the entirety of the universe, and that Andromeda was just a cloud inside it. On the other, Heber Curtis argued that Andromeda was its own island universe, a galaxy far away, as vast as our own. The debate raged, but evidence was still unclear. Both sides brought passion, data, and conviction, but neither could prove their case fully. Humanity stood on the edge of a revelation, teetering between the comfort of a smaller cosmos and the awe of an expanding one. The answer came in the 1920s, when Edwin Hubble, a man whose name would one day be carried by one of the greatest space telescopes, turned his gaze toward Andromeda. Using the 100-inch Hooker telescope at Mount Wilson Observatory, Hubble identified a special kind of star within Andromeda, Cepheid variables. These stars pulse in brightness with predictable patterns, allowing astronomers to calculate their distance, and the distances shocked the world. Andromeda wasn't just a nearby cloud, it wasn't even close. It lay 2.5 million light-years away, far beyond the edge of the Milky Way. In one stroke, Hubble proved that Andromeda was not a nebula, but an entire galaxy, and that the universe was far larger than anyone had ever dared to imagine. With that discovery, the universe expanded overnight. Suddenly, the Milky Way was just one among countless galaxies scattered through an endless cosmos. Today, we know Andromeda intimately. It is our closest spiral galaxy neighbor, visible even without a telescope. When you look up on a clear night, you are seeing across intergalactic space, your eyes catching photons that have traveled 2.5 million years to reach you. Those photons began their journey long before humans even existed, before our species was born, before the first words were spoken, before civilization arose. That smudge in the sky is more than a curiosity. It is a message from deep time, a bridge between the ancient past and the distant present. To see it is to look directly into cosmic history. Andromeda is a titan, containing more than 1 trillion stars. It dwarfs the Milky Way, which holds about 400 billion. It stretches over 200,000 light years across, making it one of the largest galaxies in our local group. Its spiral arms blaze with hot young stars, while its halo contains relics of the earliest generations of stellar light. Star clusters, planetary systems, nebulae, and black holes fill its depths. To call it a galaxy is almost misleading. It is more like a cosmic metropolis, a stellar empire, vast beyond comprehension. And yet, for all its immensity, Andromeda is not distant enough to remain apart. Gravity pulls it toward us at a speed of about 110 kilometers per second. Slowly but surely, the Milky Way and Andromeda are on a collision course destined to merge into a single supergalaxy in about 4 billion years. Why does Andromeda matter? Because it is the nearest mirror to our own Milky Way. We cannot look at our galaxy from the outside, but Andromeda offers us a glimpse of what the Milky Way might look like. Every image we take of it, every simulation we run, brings us closer to understanding our own cosmic home. Andromeda is also a reminder of perspective. On Earth, our divisions, our struggles, our ambitions can feel all-consuming, but from the vantage point of intergalactic space, they shrink to dust. To know that 1 trillion suns burn in Andromeda alone is to remember that our planet is but a grain of sand on an endless shore. We have met our neighbor, we have glimpsed its immensity, traced its discovery, and recognized its role in reshaping our understanding of the universe. But we have only stood at its edge. The real journey lies ahead. What waits if we venture inward, crossing the black ocean of space that separates us? What do we encounter as we leave the Milky Way and approach Andromeda face to face? The answer begins with a voyage, not through rockets, but through light, imagination, and the tools of astronomy. To reach Andromeda, we must cross the cosmic ocean. To stand at the edge of the Milky Way and look toward Andromeda is to confront a silence deeper than any ocean, wider than any desert, and older than time as we know it. Between us and our galactic neighbor stretches 2.5 million light years of darkness. It is tempting to call it empty, but emptiness is too simple a word. What lies between galaxies is not nothing, but a canvas upon which the universe paints its most haunting truths. Imagine leaving Earth tonight, casting off from the spiral arms of the Milky Way. At first, the stars you know remain familiar: Orion's belt, the curve of the Big Dipper, the glow of the Milky Way band stretching across the sky. But as you drift farther, those constellations unravel. Stars that once formed patterns lose their alignments, scattering as perspective changes. Soon, the comforting tapestry of the night sky dissolves into something unrecognizable. You are no longer in the neighborhood of the sun. You are leaving behind not just stars, but the entire stellar city of the Milky Way. Ahead lies a black ocean wider than thought itself, and at its far shore, the shimmering spiral of Andromeda awaits. 2.5 million light years. Numbers like these are easy to recite, but nearly impossible to grasp. Let us break it down. Light, the fastest thing in existence, racing at 300,000 kilometers per second, takes 8 minutes to travel from the sun to Earth. It takes about 5 hours to cross the solar system out to Pluto. To leave the Milky Way, light needs about 100,000 years. But to reach Andromeda, 2,500,000 years. If you were to scale the solar system down so that Earth and Sun were just 1 meter apart, Andromeda would still be more than 25 million meters away, spanning the distance of multiple continents. And yet, despite the enormity, we can see Andromeda with the naked eye. That faint patch in the night sky is a direct window into the past. Each photon that strikes your retina tonight began its journey when our ancestors were still shaping stone tools, long before the first civilizations rose. To look at Andromeda is to touch history older than humanity itself. This is the paradox of the cosmic ocean, unimaginably vast, yet traversed effortlessly by light. Silent, yet filled with whispers from the past. Empty, yet alive with meaning. Across the void, photons are the only true voyagers. They do not grow weary, they do not falter, they do not age in the way we do. For millions of years they have traveled, carrying with them the story of Andromeda. When you raise a telescope and capture an image of the galaxy, you are not seeing it as it is now. You are seeing it as it was when saber-toothed cats prowled Earth, when mammoths roamed frozen plains, when no written word yet existed. For us, astronomy is not just science, it is time travel. Light is our message in a bottle, tossed across the intergalactic sea, and every photon carries secrets: the temperature of stars, the presence of elements, the speed at which galaxies drift. By splitting light into spectra, we decode Andromeda's fingerprints. Through faint signals, we reconstruct its history. And perhaps the most humbling truth, many of the stars we see in Andromeda tonight may already be gone, exploded into supernovae, collapsed into neutron stars or black holes, but their light continues, undeterred, still journeying toward us. We see ghosts of suns that no longer shine, yet for us, they still glow. In this way, crossing the cosmic ocean is not about moving our bodies through space. It is about letting light come to us, trusting the universe to deliver its messages across epochs of silence. In the last chapter, we crossed the great intergalactic ocean, a gulf of silence where light alone is brave enough to travel. We arrived at the very outskirts of Andromeda, a faint shimmer against the blackness. From afar, it glows like a whirlpool of stars, spiraling inward toward a brilliant core. But as we approach, something unexpected greets us. It isn't the bright arms of starlight, it isn't the blaze of a trillion suns. It is something unseen, something hidden, something surrounding the galaxy like an invisible shroud. To understand Andromeda, we must first pass through its halo, a vast, ghostly sphere of matter that cannot be seen directly, yet outweighs the stars themselves. This is the invisible halo. If you could map Andromeda not by light, but by gravity, you would find that the galaxy does not end where its spiral arms fade. Instead, it is cocooned in a giant sphere extending hundreds of thousands of light years beyond the visible disk. This halo is not empty. It is filled with ancient globular clusters, tight balls of old stars that orbit like satellites. But most of its mass comes from something stranger, something that has defied our understanding for decades: dark matter. We cannot see dark matter. It emits no light, absorbs no radiation, yet its presence is undeniable. The outer stars of Andromeda whirl around the galaxy at speeds that should fling them into space. By the laws of visible matter alone, the galaxy should fly apart. And yet, it holds together. The only explanation, it is wrapped in a hidden mass, an unseen glue, binding it into shape. This invisible skeleton may account for nearly 90% of Andromeda's total mass. Without it, the galaxy would collapse into chaos. So as we enter Andromeda, our first steps are not into blazing starlight, but into a realm of mystery, a region dominated by matter we cannot see, cannot touch, yet must acknowledge. Piercing through the halo are globular clusters, ancient stellar cities, some as old as the universe itself. These clusters are tightly packed, with hundreds of thousands of stars compressed into spheres just a few dozen light years across. To visit one would be to see a night sky ablaze with countless suns, every direction filled with light. In Andromeda's halo, there are more than 500 known globular clusters, each carrying secrets of the early cosmos. Some of these clusters may predate Andromeda itself, remnants from smaller galaxies long ago consumed. They are fossils of galactic history, witnesses to cosmic mergers and collisions. These clusters remind us that halos are not truly empty. They are cemeteries and archives, storing the relics of creation. But globular clusters are only the beginning. Embedded within the halo are faint, thread-like streams, remnants of smaller galaxies torn apart by Andromeda's gravity. Astronomers have discovered trails of stars stretching across hundreds of thousands of light years, like rivers of light winding through darkness. Each stream tells a story of conquest. Andromeda has not always been the serene spiral we see. It has grown by devouring others, pulling them apart star by star, weaving their remains into its halo. In this way, Andromeda's invisible sphere is also a battlefield, scarred by cosmic violence. And if this is what the halo looks like now, what does that mean for the future when Andromeda meets the Milky Way? These streams may be previews, echoes of the kind of chaos that awaits when two giants collide. Dark matter remains the most profound mystery here. What is it? We know its weight, its influence, its ability to bend the orbits of stars. But what is it made of? Some theories suggest exotic particles that rarely interact with ordinary matter. Others imagine primordial black holes scattered like pebbles in the void. Whatever it is, dark matter makes up most of Andromeda's bulk. This truth forces a humbling thought. The galaxy's true body is not what we see, but what we don't. The glowing stars, the gas clouds, the bright spiral arms, these are only decorations on a hidden framework. The real Andromeda lies beneath visibility, cloaked in shadow. And as we pass through this invisible halo, we are reminded that reality is more than appearances. What we see is only the surface. What we don't see shapes the universe even more. Crossing the halo takes us deep into mystery and history alike. Here we witness relics of old collisions, the whispers of devoured galaxies, and the framework of dark matter binding it all together. But the halo is only the beginning. Ahead lies the visible body of Andromeda, its spiral arms glittering with new stars, blazing with nebula, echoing with supernova. We move now from the unseen to the seen, from the invisible skeleton to the glowing flesh of the galaxy. Ahead, the spiral arms open like rivers of creation. This is where light dominates, where gas and dust weave the fabric of stellar nurseries. This is where Andromeda begins to show its true face. We have crossed the invisible frontier, walked through the ghostly halo that guards the galaxy. Now we step into brilliance. Before us stretch the spiral arms, vast highways of starlight, nurseries of suns, factories of worlds. If the halo was a graveyard, the arms are a cradle. And so our journey continues inward into the spiral arms of creation. We have left the invisible halo behind, stepping out of shadow into radiance. For millions of light years we crossed emptiness, then drifted through a ghostly sphere of dark matter and forgotten relics. But now, at last, we enter the luminous body of Andromeda itself. Before us, the spiral arms unfurl like vast rivers of fire, stretching across 200,000 light years. They twist outward from the galactic bulge in elegant curves like the arms of a dancer frozen in motion. Here, light is no longer rare, it blazes. Stars by the billions burn in every direction, woven into glowing bands of blue, white, and gold. If the halo was a cemetery, this is a cradle, for in the spiral arms, the galaxy is alive. Stars are not only shining, they are being born. Andromeda is a barred spiral galaxy with two sweeping primary arms and several smaller branches. These arms are not solid structures, but density waves, regions where matter is slightly more concentrated, like a traffic jam in space. As gas clouds and stars orbit the galaxy, they slow when they enter these waves, piling up, igniting new bursts of star formation. This is why the arms glow so brightly. They are factories, cosmic assembly lines, where hydrogen clouds collapse into new suns. Some will burn hot and blue, living fast and dying young in violent supernovae. Others will ignite as steady yellow stars lasting billions of years, long enough to give rise to planets and perhaps to life. Walking these arms is like strolling through a cosmic nursery. Nebulae stretch for hundreds of light years, veils of pink and purple gas lit from within by newborn stars. Stellar winds carve out caverns, while supernovae seed the interstellar medium with heavy elements, the oxygen we breathe, the carbon in our bodies, the iron in our blood. To step into the spiral arms is to witness the alchemy of creation itself, one of A. Andromeda's most famous nurseries lies in its spiral arms, NGC 206, a star cloud so large and dense that it contains some of the most massive and luminous stars ever seen. Imagine standing there. The night sky would not be dark but ablaze. Hundreds of stars brighter than Sirius lighting up the heavens, casting shadows as strong as a full moon. Elsewhere in the arms, glowing regions like NGC 604, a giant H2 region, roar with the energy of new life. These are places where ultraviolet radiation from hot young stars excites surrounding hydrogen gas, making entire nebulae glow. Within them, thousands of stars are forming in clusters, their fates intertwined. In these arms, the galaxy is not static. It is a living organism, constantly renewing itself. Stars are born, shine, and die, seeding the next generation. The cycle of creation repeats endlessly, weaving light into the fabric of the spiral. But creation comes hand in hand with destruction. The spiral arms are also home to supernova remnants, the ghostly bubbles of expanding gas, the echoes of stars that lived fast and ended violently. Supernovae are more than explosions. They are the universe's way of recycling. Every heavy element in our bodies, from the calcium in our bones to the gold in our jewelry, was forged in the hearts of stars and scattered by such blasts. To walk the spiral arms is to be reminded that death fuels life, that endings are beginnings in disguise. Here, stars are constantly sculpting their surroundings. Radiation carves filaments of dust. Gravity sculpts clusters. Shockwaves ripple through gas clouds, triggering more star formation. It is a chain reaction of creation, stretching across tens of thousands of light years. Among these billions of stars, how many carry planets? The answer is almost certainly most of them. Modern astronomy has revealed that planets are not rare exceptions, but common outcomes of star birth. In Andromeda's arms, worlds may number in the trillions. Some orbit too close, scorched by their suns. Others drift in frozen orbits too far away. But scattered across these systems must be habitable zones where liquid water could exist, and perhaps life. Imagine civilizations rising on distant worlds in Andromeda. To them, the Milky Way would appear as a faint smudge in the sky, their neighbor, just as Andromeda is ours. Perhaps they too wonder if someone is looking back across the cosmic sea, imagining them. The spiral arms are not just cradles of stars, they are potentially cradles of life. As we journey deeper into the spiral arms, we begin to see the galaxy not as a static picture, but as a dynamic ecosystem. Gravity pulls, light sculpts, death creates, birth destroys. Every star, every nebula, every stream of gas plays a part in the grand design, and the arms themselves are transient. Over billions of years, their shapes will shift. Stars will drift, new arms may form, old ones may fade. The spiral is not eternal, but alive, like a whirlpool, forever in motion. Here we see the truth of galaxies. They are not monuments, they are processes, living, breathing structures, carrying the rhythm of creation within them. The spiral arms have shown us creation and destruction intertwined, light and darkness in harmony. They are the veins of the galaxy, carrying the lifeblood of stars into the core. But beyond them lies something even denser, even older, the galactic bulge, a city of ancient suns clustered so tightly that night never falls. To leave the arms is to step into this stellar metropolis, a place where stars crowd together like buildings in a cosmic skyline. And so our journey continues inward. From the cradle of the spiral arms, we move into the beating heart of Andromeda's stellar city. We leave behind the graceful sweep of Andromeda's spiral arms, with their glowing nurseries and restless clouds, and approach something very different. Ahead, the spiral arms funnel inward, curving toward a bright, swollen center. This is not a cradle of youth. This is an ancient metropolis, a galactic downtown where stars are packed so densely that darkness itself struggles to survive. Here lies the galactic bulge of Andromeda, a region of extreme density where the sky would blaze not with hundreds of stars, but with thousands, even tens of thousands. If the spiral arms are the suburbs, spread wide and filled with room to grow, then the bulge is the crowded city core, old, brilliant, restless, and eternal. This is the stellar city. As we step inside, the first sensation is brightness. Imagine standing on a planet deep in Andromeda's bulge. Night would never truly fall. Every direction would reveal a sky blazing with countless stars, each closer than the nearest bright stars in our own neighborhood. Shadows would stretch in overlapping directions, cast by dozens of suns. The concept of a dark night would vanish. Most of these stars are old, far older than our sun. They belong to the earliest generations of Andromeda, born when the galaxy itself was still young. Many are red giants, swollen and glowing, nearing the ends of their lives. Others are compact dwarfs, survivors of long stellar histories. Together, they form a thrumming hive of ancient light. Here, the galaxy is no longer spacious. It is congested, crowded, vibrant. Gravity has drawn stars together into a city where distances shrink and interactions multiply. In the spiral arms, stars orbit in graceful arcs, separated by light years of emptiness. But in the bulge, the traffic thickens. Stars race around the galactic core in tight orbits, pulled by the immense gravity of Andromeda's central mass. Collisions between stars remain rare, but encounters are frequent. Gravitational tugs distort orbits. Binary systems are ripped apart. Rogue planets are cast into interstellar space. In some regions, stars swing so close that their atmospheres brush against one another, exchanging material like neighbors passing whispers. The stellar city is alive with motion. Each star is a traveler, each orbit a path, each cluster a neighborhood in this ancient metropolis. Scattered through the bulge are dense stellar clusters like neighborhoods within the city. Some are globular clusters, remnants of Andromeda's youth, their stars tightly bound together. Others are open clusters that have migrated inward over time. But beyond ordinary stars, this region harbors the exotic. White dwarfs, embers of long-dead suns, drift among the crowd. Neutron stars, collapsed stellar cores denser than anything except black holes, orbit invisibly, pulsing with radiation. There may even be stellar mass black holes, invisible predators circling in the shadows, detectable only by the way they bend light or tug on nearby stars. The stellar city is not only a place of brilliance but of strangeness. It is a catalogue of stellar evolution, a gallery of every possible fate a star can meet. Standing here in thought, we cannot help but draw comparisons to our own cities on Earth. Like human cities, the galactic bulge is crowded, noisy and restless. Its skyscrapers are red giants towering above their neighbors. Its streets are orbits weaving through gravitational lanes. Its citizens are stars of every type and age, from fiery newborns to fading elders. And just as Earth's cities are shaped by history, wars, migrations and collapses, so too is Andromeda's core. Every star here carries a story written in its light, a record of the galaxy's past. By studying these stars, astronomers decode Andromeda's biograph, and when its earliest stars formed, when it merged with others, how its heart has grown. The stellar city is both a living present and a frozen archive. Yet for all its brilliance, the stellar city is not the final destination. It is only the prelude. For at the very center, hidden within this crowded metropolis, lies something darker, heavier, and infinitely stranger, Andromeda's supermassive black hole. The bulge prepares us for it. The density increases, the orbits grow tighter, the light intensifies. It is as if every star is drawn toward a gravitational drumbeat, a rhythm set by something deeper than light. The stellar city leads us inevitably inward toward the heart of the galaxy, and at that heart waits not light, but shadow. From the brilliance of the stellar city, we now approach the ultimate paradox, a place where light itself cannot escape. At the very center of Andromeda lurks a force of unimaginable gravity, a monster in the dark. It is not a star, but a devourer of stars, not a source of light, but a prison for it. We have walked the crowded boulevards of the stellar city, where stars blaze in every direction, where night itself seems impossible. Yet even here, at the very heart of Andromeda, there is a place where light falters, gravity tightens its grip, stars bend in their paths, space curves inward like a whirlpool. At the very center of Andromeda lurks something so strange that even the brightest suns cannot resist it, a supermassive black hole. Astronomers call it M31. We may call it something simpler, the monster in the dark. This is not a metaphorical monster, it is real. A single object weighing perhaps 100 million times the mass of the Sun, packed into a space no larger than our solar system. Around it, stars race at breakneck speeds, whipped into frantic orbits. Closer still, gas clouds are torn apart, their atoms shredded and heated until they glow with deadly energy, and then inevitably they vanish, swallowed by a horizon from which not even light can return. The stellar city dazzles us with brilliance, but the monster at its heart is a reminder. In galaxies as in life, the brightest beauty is often ruled by the deepest darkness. A black hole is not a hole in the ordinary sense. It is a region where gravity has crushed matter into such density that escape is impossible. At its boundary, called the event horizon, the escape velocity exceeds the speed of light. Once crossed, no signal can return. To the outside universe, whatever enters is lost forever.
For Andromeda's black hole, this horizon spans only a few dozen astronomical units, tiny compared to the galaxy itself. And yet, its influence extends far beyond. Stars, thousands of light years away, still feel its pull. It is like a king whose throne is small, but whose rule stretches across an empire. We know it is there not because we can see it, we cannot, but because of how it moves its surroundings, by trance. Acting the velocities of stars close to the galactic center, astronomers have inferred its presence, just as detectives deduce a hidden culprit by the disturbances they leave behind. Around the black hole lies a maelstrom, an accretion disk of gas, dust, and stellar debris spiraling inward. As this matter falls, it heats to millions of degrees, releasing X-rays and ultraviolet light. To an observer, the black hole is not black at all, but ringed by a brilliant halo of energy. This accretion process is among the most efficient engines in the universe. Gram for gram, matter falling into a black hole releases more energy than nuclear fusion at the core of a star. Some of this energy escapes in the form of radiation, some in powerful relativistic jets, streams of particles accelerated to near light speed and shot outward for thousands of light years. Though Andromeda's central black hole is relatively quiet today, it may once have been a quasar, blazing so brightly that it outshone the entire galaxy around it. In its youth, the monster would have fed voraciously, lighting the cosmos like a beacon. What we see now is a predator at rest, but not asleep. Orbiting close to the black hole are stars caught in its grip, moving at blistering speeds. To circle the galactic center is to play a dangerous game, for a single miscalculation can lead to destruction. Some stars are stretched into long streams, shredded by tidal forces in a process aptly named spaghettification. Others are slingshotted outward, flung from the galaxy entirely at hypervelocity, never to return. This stellar ballet is not random. It is orchestrated by the invisible hand of gravity, choreographed by the black hole itself. Every orbit, every collision, every disappearance is part of its silent dominion. To imagine standing nearby is impossible, for no solid ground exists here. But picture hovering in a ship on the edge of the event horizon. Space twisted, time slowed, stars blurred into streaks as gravity bends their light. The closer you drift, the more reality distorts, until the universe itself appears to funnel into darkness. What happens inside the black hole? Here lies one of science's greatest mysteries. General relativity tells us that matter collapses into a singularity, a point of infinite density. Quantum mechanics rebels against this idea, suggesting something else must happen, some unknown law yet to be discovered. Is the singularity real? Does the black hole destroy information, or is it preserved in ways we do not understand? Could black holes be gateways, not to other universes, as science fiction imagines, but to deeper truths of physics itself? Standing at the edge of Andromeda's black hole, we are not just at the center of a galaxy, we are at the frontier of knowledge. Here, science bends toward philosophy, and philosophy bends toward silence. Why does the galaxy need such a monster? Paradoxically, black holes may not only destroy but also create. By regulating star formation, shaping galactic cores, and driving outflows of energy, they help galaxies evolve. Without their influence, spiral galaxies might look very different, their arms less defined, their growth unchecked. The monster in the dark is not merely a predator, it is also an architect sculpting the city around it. It reminds us that creation and destruction are not opposites, but partners, entwined in cosmic rhythm. We have seen the monster that rules Andromeda's heart, invisible yet undeniable, destructive yet creative. But Andromeda does not live alone. It is moving, slowly but surely, toward our own Milky Way. The gravity of two giants is drawing them together, their fates locked. Ahead lies a future both violent and beautiful, a galactic collision. Two spirals merging, their stars scattering, their black holes spiraling toward each other in a final dance. And so, from the shadow of the monster, we turn our eyes forward. The next chapter is not about the present, but the destiny of galaxies themselves. The black hole is the ruler of Andromeda today. But what happens when Andromeda meets its equal? When two monsters face one another across the battlefield of merging galaxies? Ahead lies a vision billions of years in the making, the collision of the Milky Way and Andromeda.
Andromeda's black hole is not small. Astronomers estimate its mass at around 140 million times that of the Sun, nearly 35 times larger than Sagittarius A, the black hole at the heart of our own Milky Way. To put this in perspective, if Andromeda's black hole were placed in the center of our solar system, its event horizon would easily engulf Mercury's orbit. A single teaspoon of material from near its core would weigh billions of tons. Stars orbiting close to it whip around at speeds exceeding 1,000 kilometers per second, faster than Earth orbits the Sun. These numbers do not merely impress, they redefine scale. Black holes like this are cosmic engines, holding galaxies together with gravity while feeding on whatever dares to approach. And yet, despite its immensity, the black hole remains invisible. Its event horizon is a border of silence. No telescope, no camera, no eye can peer inside. For centuries, the idea of a black hole was dismissed as fantasy. Even Einstein himself, whose equations predicted their existence, doubted they could be real. The thought of matter collapsing into infinite density seemed absurd. But as the 20th century unfolded, evidence mounted. Astronomers tracked the speeds of stars near galactic centers and found them whipping around invisible masses. In 1993, studies of Andromeda revealed just such motion, too fast, too compact, to be explained by anything but a supermassive black hole. We had found the monster, not by seeing it, but by witnessing its dominion. Like a king never glimpsed directly, but whose subjects all bow, the black hole announced itself by the movements of everything around it. What would it be like to approach the edge of Andromeda's black hole? Imagine drifting toward the event horizon in a vessel, with no hope of return. Time itself would stretch. To an outside observer, your descent would slow, your ship appear to freeze on the brink forever, but to you the fall would feel swift, unstoppable. The light of the galaxy would warp around you, stars would smear into arcs bent by gravity's lens. The accretion disk, glowing with deadly radiation, would encircle the black hole like a ring of fire, and then, as you crossed the horizon, all of Andromeda would vanish in an instant. Inside, physics as we know it collapses. Space and time trade roles. Every path leads inward, and somewhere beyond our equations lies the singularity, a concept so extreme that even our best science cannot describe it. It is the ultimate boundary, the edge of knowledge itself. Why dwell on such darkness? Because the monster teaches us more than fear. It teaches us paradox, that what seems destructive can also be creative, that the end of stars seeds the birth of others, that the silence at the center of a galaxy can be the very thing holding its light together. For philosophers, the black hole is a mirror of mortality. Just as no star can escape its pull forever, no life can escape its end. And yet, just as galaxies thrive around black holes, so too can meaning thrive around limits. It is the finite that gives shape to the infinite. In this way, Andromeda's black hole is not only a monster, it is also a teacher. But Andromeda's monster does not reign alone forever. Across the cosmic ocean in the center of the Milky Way, our own black hole waits. Sagittarius A, smaller but no less formidable, is locked in a slow dance with its counterpart. In about 4 billion years, when the Milky Way and Andromeda merge, the two black holes will spiral toward each other, drawn together by gravity. They will circle closer and closer, releasing ripples in space-time itself, gravitational waves that echo across the universe. And at last they will collide, merging into a single black hole, even more massive, even more dominant. The monsters will meet, and when they do, the galaxy we call home will never be the same. We began in the light of the stellar city, and we have descended into its shadow. We have seen Andromeda's black hole, invisible yet irresistible, terrifying yet essential. It is the monster in the dark, the ruler of the galaxy, the paradox of destruction and creation bound into one. But our journey cannot end here. The monster is only part of Andromeda's story. For galaxies are not still, they move, they merge, they evolve. The black hole teaches us about the present, but the future of Andromeda lies in something even larger, its collision with our own Milky Way. From shadow, we turn toward destiny. Ahead lies chaos, beauty, and transformation on a cosmic scale. From the monster's throne, we look outward and forward. Andromeda is not just a galaxy, it is a traveler speeding toward us. The question is not if it will collide with the Milky Way, but when. What happens when two spirals meet? When two black holes duel? When two cities of stars become one? We leave behind the silence of Andromeda's central black hole and turn our gaze outward, across the galaxy's arms, past its halo, and back into the intergalactic sea. There, in the darkness, lies another spiral giant, our own Milky Way. For billions of years, these two galaxies have lived as neighbors, bound by gravity, circling one another like wary dancers. But their distance is shrinking, their orbits are not stable, the pull is relentless. The future is written in their motions. The Milky Way and Andromeda are on a collision course. In about 4 billion years, the two largest galaxies of the local group will crash together in a cosmic union. It will not be a gentle meeting. It will be a slow-motion cataclysm that lasts billions of years. Stars scattering, gas clouds colliding, black holes spiraling toward one another in a final duel. This is not speculation. This is destiny. The two galaxies are already moving toward each other at a speed of 110 kilometers per second. The question is not if, it is only when. And so we step into the future. From the monster in the dark, we now witness a spectacle grander still, the collision of galaxies. At first, the approach will be subtle. From Earth, future astronomers will notice Andromeda growing larger in the night sky, its faint smudge expanding into a sprawling spiral visible to the naked eye. Over millions of years, it will loom brighter, its arms stretching wide like a rival city on the horizon. When the two galaxies finally begin to touch, stars will not collide head-on. The distances between them are vast. Instead, their gas clouds will crash and compress, igniting bursts of star formation. New suns will blaze into life by the millions, galaxies briefly turning into fireworks factories. The night sky of Earth, if Earth still exists and life still remains, will be transformed. Instead of a scattering of stars, the heavens will be filled with vast arcs of light, two galaxies entwined in luminous embrace. As the galaxies interpenetrate, their spiral structures will warp and twist. Tidal forces will stretch arms into long streams of stars, flinging some into intergalactic space. Others will fall inward, drawn toward the merging cores. Our sun, still burning by then, will likely be cast into a new orbit, slingshotted across the chaos. Some simulations suggest it could be hurled outward into the far reaches of the merged galaxy. Others place it in a new trajectory closer to the center. For any beings still clinging to Earth, the sky will change forever. Familiar constellations will vanish, replaced by alien patterns formed from Andromeda's stars. The galaxies will not pass through one another once, but several times. Like dancers locked in orbit, they will sweep past, pull apart, and fall back again, each encounter more violent than the last. Each pass will strip more material, stir more chaos, and drag them closer together. This is a collision in slow motion, unfolding not in minutes or years, but over billions of years. To us, it is unimaginable. To the universe, it is routine. What happens to the stars within? Remarkably, most will never collide. The vast distances ensure that stars slip past one another unaffected, but their orbits will change dramatically. Some will be slung outward into the void, becoming rogue stars, wandering intergalactic space forever. Others will fall inward, circling closer to the cores. Some planetary systems may be torn apart by passing stars. Planets may be ejected into the darkness, their suns stolen or destroyed. For Earth, survival depends on timing. By the time Andromeda and the Milky Way collide, our sun will be nearing the end of its life, expanding into a red giant. Humanity, if it still exists, will have long since left Earth behind, the Colossi. On will matter less to life on Earth than to the structure of the cosmos itself. But to witness it would be awe beyond words. Imagine standing on a world orbiting a star in the midst of the merger. The sky would not simply show stars. It would blaze with arcs of light, galaxies woven together in a luminous storm. It would be chaos, but chaos drenched in beauty. At the very center of each galaxy waits a supermassive black hole, Sagittarius A in the Milky Way, M31 in Andromeda. As the galaxies merge, these titans will begin their slow spiral toward one another, bound by gravity. Over millions of years, they will circle closer, ejecting stars as they lose energy. Each orbit will tighten, their dance growing faster. Finally, they will collide in a cataclysm of space-time. The merger will release gravitational waves, ripples in the fabric of the universe itself.
carrying away energy at the speed of light. The result will be a single black hole, more massive than either before, perhaps hundreds of millions of solar masses anchoring the new galaxy. The duel will end, not with one victor, but with unification. After billions of years of chaos, the Milky Way and Andromeda will settle into a new form. Their spiral arms will be gone, shredded by tidal forces. In their place will be a vast elliptical galaxy, smooth and rounded, with stars orbiting in random directions rather than ordered spirals. Astronomers call it Milkdromeda. It will be larger than either galaxy today, containing trillions of stars. The local group will be reshaped, dominated by this one massive structure. For any civilization alive then, the sky will be filled with light. But the delicate beauty of spiral arms will be replaced by the diffuse glow of an elliptical giant. The universe erases and remakes, destroys and creates. What was two becomes one. What was familiar becomes strange. To think of galaxies colliding is to confront our smallness. The timescales are beyond human measure. The civilizations rise and fall in the blink of a galactic eye. The stars that light our myths today will not even exist by the time the collision is complete. And yet there is comfort here. Collisions are not endings, but transformations. The universe is not fragile, it is resilient. Galaxies do not die when they collide. They change shape, they evolve, they grow. For us, the coming collision is not doom, but perspective. It is a reminder that change is the only constant, that even the grandest structures in the universe are in motion, reshaping, becoming something new. We have watched galaxies collide, spirals dissolve, and monsters merge. We have seen the chaos of creation on the grandest stage. But Andromeda's story is not only about its fate, it is also about what it reveals, about galaxies beyond, about the nature of the cosmos itself. For in Andromeda we glimpse a mirror, a reflection not just of our own Milky Way, but of every galaxy in the universe. To study Andromeda is to study the destiny of all galaxies. And so we move onward. From the chaos of collision, we turn toward a wider view, asking what Andromeda teaches us about the structure of the cosmos. The collision shows us destiny, but beyond Andromeda, beyond the Milky Way, lies a still greater pattern. Galaxies are not islands. They are threads woven into the fabric of the universe. To truly understand Andromeda, we must step back even farther and see how it fits into the mirror of infinity. The collision of Andromeda and the Milky Way is not the end of a story, it is only a chapter. For if we step back, if we widen our lens beyond two galaxies, something larger emerges, a grand design stretching far beyond the reach of any single merger. Andromeda is not an isolated wanderer. It is part of a structure so immense that no human map can contain it. It is one thread in a tapestry of billions woven into what we call the cosmic web. When we gaze at Andromeda, we are not only looking at a neighbor, we are looking into a mirror of infinity, a reflection of the processes that shape the entire universe. When Edwin Hubble proved that Andromeda was not a nebula but a galaxy, humanity's sense of scale shattered. We realized our Milky Way was not the universe, but one island among many. Today we know there are more than 2 trillion galaxies in the observable cosmos. But galaxies are not evenly scattered. They gather into clusters, clusters into superclusters, and superclusters into vast filaments. Between these filaments lie great voids, immense expanses, almost completely empty of matter. Andromeda, along with the Milky Way and a few dozen smaller galaxies, forms the local group. The local group itself is a suburb of the Laniakea supercluster, a continent of galaxies bound together across 500 million light-years. In this way, Andromeda is both small and vast. Small because it is only one galaxy among trillions. Vast because it reflects the same cosmic structures that scale up endlessly, repeating like patterns in a fractal. The universe is not random. On the largest scales, matter arranges itself into a cosmic web, a pattern of filaments and voids spanning billions of light-years. This structure formed after the Big Bang, when tiny fluctuations in density grew under gravity, pulling matter into threads. Along these filaments, galaxies form and cluster, while oids expand into darkness. Seen from afar, the universe resembles a vast neural network, or perhaps the filigree of frost on a window pane. Andromeda is a single node in this web, glowing at an intersection of cosmic filaments. Its story is the same as every galaxy's, born in the web, fed by it, and ultimately merging back into it. To understand Andromeda, then, is to understand the universe itself. Its collisions, its stars, its black hole, these are not unique. They are reflections of universal laws written everywhere across infinity. But the mirror is not only spatial, it is temporal. To look at Andromeda is to look into the past. Its light has traveled 2.5 million years to reach us. Every galaxy we see is another mirror, reflecting not its present self, but its ancient history. The deeper we look into the universe, the farther back in time we see. Some galaxies appear as they were billions of years ago, when the first stars were just igniting. In this way, telescopes are not only spatial instruments, but time machines, allowing us to witness the evolution of galaxies across cosmic history. Andromeda is a nearby mirror, showing us what a mature spiral galaxy looks like today. Others, farther away, show us galaxies in their youth. Together, they form a mosaic, a mirror of infinity across time as well as space. Step back even farther and the patterns repeat. Small galaxies merge into larger ones. Large galaxies fall into clusters. Clusters stream into superclusters. Superclusters lace into the cosmic web and beyond the observable universe. Who can say? This repetition gives rise to a thought. Perhaps the universe is not only vast, but self-similar. Perhaps Andromeda is not just a neighbor, but a model, a single example of the laws that govern all galaxies. To study it is to study everything. Like a mirror reflecting a mirror, the cosmos shows itself in endless recursion. Infinity is not abstract, it is written into the very structure of matter and time. What does this mean for us? When we look at Andromeda, we are also looking at ourselves, for the atoms in our bodies were forged in stars not unlike its own. The collisions that shaped its halo mirror those that shaped the Milky Way. Its destiny, those collision, merger, rebirth is ours as well. We are not separate from the cosmic web. We are threads woven into it. The neurons in our brains resemble the filaments of galaxies. The stories of our civilizations echo the rise and fall of stars. To study Andromeda is to study humanity's reflection on the grandest scale. And so the mirror of infinity is not distant, it is intimate. It tells us that we are not observers of the cosmos, but participants in its endless unfolding. The mirror of infinity shows us scale, structure, and time beyond imagination, but it also shows us connection, that galaxies are not alone, and neither are we. That the universe is not random chaos but patterned order, that Andromeda, in all its brilliance and shadow, is both unique and universal. And yet, beyond the cosmic web, beyond infinity, there lies one more question. What does this mean for us, here and now? Why do we seek these journeys? Why do we look outward at all? The next step in our voyage is not into the galaxy itself, but into our own minds, into the human perspective that gives these infinities meaning. The cosmic web we see is only half the story. Just as Andromeda itself is wrapped in an invisible halo of dark matter, so too is the universe woven with threads of the unseen. Astronomers have mapped the large-scale structure of the cosmos using a technique called gravitational lensing. When light from distant galaxies passes near massive structures, it bends. By studying these distortions, we can trace the presence of invisible matter. What emerges is breathtaking. The luminous filaments of galaxies are merely the tips of vast, dark sea, of folds, strands of unseen mass stretching across billions of light years. Andromeda, the Milky Way, every galaxy we know, they are beads strung on invisible wires. The visible universe is a pearl necklace. The dark matter is the string. Without it, galaxies could not exist. Without it, the cosmic web would unravel. This realization deepens the mirror. The universe we perceive with our eyes is only a fraction of reality. Infinity includes not only what is seen, but what is hidden. If dark matter is the skeleton of the cosmos, then light is its sculptor. Over billions of years, galaxies ignite along the filaments, burning hydrogen into heavier elements, sending radiation across the void. These galaxies act like lanterns, illuminating the structure of the web itself. But light has another role. It carries the record of the universe's past. Telescopes like Hubble and the James Webb Space Telescope allow us to peer deeper and deeper, catching light that has been traveling for 13 billion years. These faint smudges are galaxies in their infancy, small and irregular, merging and growing into spirals like Andromeda. In this way, Andromeda is not only a mirror of our present universe, but a descendant of countless earlier collisions, a mature chapter in an infinite book. To see it is to glimpse the evolution of galaxies across time, and to recognize that our own Milky Way is walking the same path. Patterns echo across scales. The cosmic web, with its nodes and filaments, bears a striking resemblance to the neural network of the human brain. Both are systems of connections, hubs, and flows of energy. This resemblance is more than poetic. It suggests that complexity arises from similar principles across vastly different scales. Just as neurons self-organize into thought, galaxies self-organize into cosmic structure. The brain reflects the universe reflects the brain. And so when we speak of the mirror of infinity, we are not only talking about galaxies, we are talking about ourselves. The cosmos is not a distant stage on which we are irrelevant actors. It is a system in which we are embedded, structured, and reflected. When we gaze at Andromeda, we are, in a sense, gazing at the mind of the universe and at the echoes of our own. Infinity can be overwhelming. The numbers defy comprehension. Trillions of galaxies, quadrillions of stars, endless webs of dark matter and light. Against such immensity, the human heart seems small, our lives brief. And yet, infinity without finitude is meaningless. Just as a painting needs a frame, so too does infinity need boundaries to give it shape. We are that frame. Our lives, short as they are, provide contrast against eternity. Our questions, fragile as they seem, give the cosmos meaning. Andromeda, in all its scale, does not diminish us. It contextualizes us. It reminds us that the atoms of our bodies were born in stars like its own, that our future is bound to its future, that our fate is written in the same cosmic script. The mirror of infinity is not a reminder of insignificance. It is a reminder of belonging. When we place Andromeda within the cosmic web, we see not just a galaxy but a reflection of the whole. Its halo of dark matter mirrors the universe's hidden scaffolding. Its spiral arms mirror the groat H of structure along cosmic filaments. Its collision with the Milky Way mirrors the endless mergers that shape galaxies everywhere. And in that reflection we find ourselves. For if Andromeda is a mirror of infinity, then infinity includes us too. Our lives, our thoughts, our questions, they are part of the pattern. We began this journey at the edge of perception, mistaking Andromeda for a faint star. We crossed the intergalactic ocean, entered its halo, wandered its arms, passed through its stellar city, faced its central monster, and looked ahead to its collision with our own. Now, stepping back, we see it for what it truly is, a mirror of the universe, a fragment of infinity, a reflection of everything. But the journey is not over. For even infinity cannot answer the deepest question: why do we look at all? Why do we seek Andromeda, map its halo, measure its black hole, and dream of its collision? What compels fragile beings to ask about the eternal? The next chapter turns the mirror back on us, not on galaxies, not on infinity, but on humanity itself. For the story of Andromeda is also the story of those who tell it. From the mirror of infinity, we return to our own reflection. What does it mean to live in a universe where galaxies are born and die, where infinity stretches without end? What lessons does Andromeda give us about fragility, about resilience, about meaning? We have spent this journey traveling outward, across oceans of darkness, through halos of invisible matter, into arms of creation, into the heart of a stellar city, and finally into the abyss of a supermassive black hole. We have watched galaxies collide, and we have stepped back to see the universe itself as a web without end. But now, the direction changes. From infinity, we return to the finite. From galaxies, we return to ourselves. For what is the point of exploring Andromeda or the universe at large, if not to understand what it means for us? The truth is simple. The universe is not only out there, it is also in here. The story of Andromeda is not separate from humanity's story. It is a reflection of it. From the moment ancient eyes looked up at the faint smudge of Andromeda in the night sky, the galaxy became part of us. They did not know its scale, they did not know its distance, but they felt its mystery. That mystery is what gave rise to science, philosophy, and myth. The first astronomers charted its position. The first poets wove it into stories. The first children asked, "What is that cloud in the sky?" And though they did not have answers, they had wonder. That wonder remains. Even today, when we know that Andromeda is a trillion suns bound in a spiral, it still humbles us. Facts do not erase awe, knowledge deepens it, and so Andromeda becomes not just an object of astronomy, but a mirror of human curiosity. To confront Andromeda is to confront scale, a galaxy so large that Earth is invisible within it, so far that its light predates humanity itself. Against this immensity, we seem fragile. Our lifespans are a flicker, our civilizations are a heartbeat, our planet is a grain of sand on a cosmic shore. And yet, fragility is not futility. If anything, it gives us meaning. To be small is not to be irrelevant, it is to be rare. In all the vastness we have surveyed, we have not yet found another Earth, another humanity. Andromeda may harbor life, perhaps civilizations of its own, but we do not know. What we do know is that here on this planet, consciousness has emerged. The ability to look at the universe and wonder about it. This is our strength. Against infinity, we have awareness. Andromeda offers us perspective. It reminds us that the boundaries we draw, nations, conflicts, ambitions, are smaller than small, that what divides us pales before what unites us, our shared place in the cosmos. When astronauts look back at Earth from orbit, they speak of the overview effect, the sudden realization that borders are illusions, that humanity is one. Andromeda gives us a similar effect, stretched across greater distance. It says, you are not only one people on one planet, you are citizens of a galaxy, neighbors to another, participants in a universe without end. Perspective is not despair, it is liberation. To see ourselves against the backdrop of Andromeda is to realize that our greatest responsibility is not only to survive, but to thrive, to create, to seek, to remember. Every photon from Andromeda carries a story of time. When it began its journey, there were no pyramids, no empires, no religions, no nations. Humanity was still primitive, fragile, unformed. In the time it took that light to cross the void, we learned to speak, to write, to build, to question the stars themselves. What will happen in the next 2.5 million years? When tonight's photons arrive on some future world, will there still be humans to see them? Will there be another species born of us, evolved or engineered, standing beneath the sky? The light of Andromeda does not only show us the past, it asks us to imagine the future. It reminds us that time is not only behind us, but ahead of us, that our story, fragile as it seems, may be far from over. The black hole at Andromeda's core showed us mortality. Every star must end, every orbit must decay, every structure, no matter how vast, will one day dissolve. But the galaxy itself shows us something else, immortality. Not of the individual, but of the process. Stars die, but their elements seed new stars. Galaxies collide, but from their wreckage, a new galaxy is born. So too with humanity. Individuals pass, civilizations fall. But the drive to question, to create, to explore, that persists. We are mortal beings with immortal longings. In Andromeda's endless cycles, we glimpse our own, fragile bodies but infinite spirit. Science can tell us what Andromeda is, how it formed, where it is going, but science alone cannot tell us what it means. That is for us to decide. For some, Andromeda is a source of humility. For others, inspiration. For still others, faith. The meaning of the galaxy is not in its stars, but in our response to them. Meaning is not given by the universe, it is made by those who live within it. And that perhaps is the greatest perspective of all, that in a universe where galaxies live and die without care, humanity can care. That in a cosmos indifferent to our fate, we can choose to love, to seek, to hope. The human perspective does not diminish Andromeda, it completes it, for a galaxy is only light without someone to see it, only silence without someone to hear it. Andromeda's true power is not only in its trillion stars, but in its ability to awaken awe in a fragile mind on a small planet 2 million light-years away. We began this journey by mistaking Andromeda for a faint star. Now we know it as a galaxy, a neighbor, a mirror, a destiny. But most of all, we know it as a teacher, one that reminds us of our fragility, our resilience, and our potential. The final step is to bring it all together, to take the halo, the arms, the city, the monster, the collision, the mirror, and the human reflection, and weave them into one conclusion. From the human heart, we move to the final chapter. The story of Andromeda is not only about stars and galaxies, but about journeys, outward and inward, scientific and spiritual. The question remains, when the journey ends, what have we truly learned?
Every journey has an ending, not because there is no more to see, but because there comes a moment when the traveler must pause, turn back, and take in all that has been discovered. We began with a faint blur in the night sky, a ghostly cloud mistaken for a star. We crossed the ocean of intergalactic space, entered Andromeda's invisible halo, wandered its spiral arms, walked through its stellar city, and faced the monster at its heart. We leapt forward in time to witness its collision with our own galaxy, then stepped back to see it woven into the mirror of infinity. Finally, we turned inward to understand what it all means for us. Now we stand at the end of the journey, and the question is simple: what have we learned? Andromeda taught us perspective, that the universe is larger than our imagination, older than our histories, deeper than our philosophies, that we are not the center but participants in a cosmic story billions of years in the making. Perspective humbles us. It shows us that our quarrels, our ambitions, our fears, they are smaller than a grain of sand on the shore of infinity. And yet paradoxically, perspective also empowers us. For in seeing how small we are, we recognize how precious we are. The universe may teem with galaxies, but consciousness, the ability to look at them and wonder, is rare. To know our scale is not to lose meaning, but to discover it. The spiral arms showed us creation, stars born in clouds of gas, shining for millions or billions of years, seeding worlds with heavy elements. Without these processes, there would be no planets, no oceans, no life. Every atom in our bodies was once forged in a star, not unlike those of Andromeda. Creation is not static, it is ongoing. Even now in Andromeda, new stars are forming, new worlds are circling, new stories may be beginning. Creation is the rhythm of the cosmos, the pulse that drives galaxies, the fire that lights infinity. The lesson is simple: we are products of this creation and participants in it. To live is to continue the story of the stars. But Andromeda also taught us destruction, supernovae blasting apart suns, black holes swallowing light, galaxies colliding and tearing themselves into new forms. Destruction too is part of the story. Without it, there is no renewal. The heavy elements that make life possible were scattered by dying stars. The growth of galaxies is driven by mergers and collisions. Even black holes, those monsters in the dark, regulate the structure of galaxies, preventing chaos, shaping order. In the cosmos, destruction is never the end. It is the beginning of something new. Perhaps the most profound lesson is change. Nothing in the universe is static. Stars are born and die. Galaxies grow and collide. Even infinity evolves. Andromeda itself is proof. Once, it was a smaller galaxy, built from mergers. In the future, it will no longer exist as we know it, but as Milkdromeda, an elliptical giant born from collision with the Milky Way. Change is not an accident. It is the essence of existence. To resist it is futile. To embrace it is wisdom. For in change there is continuity. In endings there are beginnings. In the end, Andromeda shows us that everything is connected. Stars are linked to galaxies, galaxies to the cosmic web to infinity, and all of it to us. When we breathe, we inhale atoms made in stars. When we think, our neurons echo the structure of galaxies. When we dream of places like Andromeda. The connection is not metaphorical, it is physical, real, profound. We are the universe looking at itself. We are Andromeda reflected in human eyes. And so we return. The journey to Andromeda was never only about the galaxy itself, it was about us. About what we discover when we look outward, about how we grow when we confront scale, creation, destruction, change, and connection. We return with awe, with humility, with questions still unanswered and perhaps unanswerable, but also with something deeper, the sense that to live, to question, to wonder, is to participate in the infinite. Andromeda is no longer a distant smudge. It is a teacher, a mirror, a destiny, a companion. The journey ends not in silence, but in understanding. That the universe is vast, that life is fragile, that meaning is not given but made, that every night sky holds not just stars, but stories. And when you look up and see that faint blur in the darkness, know this: you are not only looking at Andromeda, you are looking at yourself, you are looking at the journey that binds us all, from the first atoms forged in stars to the galaxies yet to be born.